Welcome back, polar bears and polar cubs. It's time to talk about the mole. And we're talking about molar mass and molar conversions. This is the most important thing in chemistry, is the mole. That's why we celebrate Mole Day. Okay, so let's talk about this. How many atoms of an element are present in a sample of the element with a measurable mass? That's what we want to know. So in other words, if you have 12 grams of carbon, how many atoms of carbon would be in there? And this is where molar conversions come into effect, and they become a factor. So when you have 12 grams of carbon, 12, you exactly have 1 mole. Notice how we drop that E, and it becomes mole when we're using it as a unit. So big things that we need to know. So inside of 12 grams of carbon, you're going to have what is deemed to be Avogadros number of atoms. So this big number right here, 6.022 times 10 to the 23rd, that is Avogadro's number. Avogadro, not avocado. You might like guacamole, but we're talking about Avogadro. So 12 grams is going to be that number of atoms. So you have this conversion factor that comes apart. It says particles. Now, with particles, that can stand for 4 things down right here that you need to know: atoms, molecules, ions, or formula units. So atoms are an element with no charge. Molecules would be anything that is covalently bonded, meaning non-metals bonded together. Ions is anything with a net charge, so it's going to have a positive or a negative charge on it. And then formula units would be anything that is ionically bonded. So that means that it has a metal plus a non-metal, or it has polyatomic ions. So what does 1 mole really tell us? Well, no matter what we have, if we have 1 mole of something, we have 6.022 times 10 to the 23rd atoms of sodium, or atoms of whatever, if we have moles of one element. Now, if we have molecules of H2O and we have 1 mole of them, how many molecules will we have? Well, you guessed it, that's 6.022 times 10 to the 23rd molecules of H2O. So remember, 1 mole of anything will equal Avogadro's number of that thing. Okay, so a mole of sodium equals Avogadro's number of atoms of sodium that you have. And then we have the other side of the equation, which is molar mass. Okay, it's molar mass. And with molar mass, that's the grams on the periodic table, and we're going to the hundredths place, and then our units are going to be grams/mole. So it actually tells us that 1 mole of a element is equal to the grams of the element off the periodic table. So for example, if you have 6.022 times 10 to the 23rd iron atoms, you have 1 mole of iron, which is also 55.85 grams of iron. Okay, so this kind of little conversion line is very important when beginning your journey through the mole. Again, 55.85 grams per mole equals a molar mass of iron. So how do you calculate molar mass? Okay, well, molar mass is, you find the molar mass off the periodic table, you multiply it by how many moles you have, and that will give you the molar mass. So all of these we're just finding the molar mass of 1 mole. So with this one, you have a sodium and a chlorine. So you take the sodium mass and the chlorine mass, you add them up, giving you the molar mass of sodium chloride. When you come to something that's a little more complex, this is called copper 2 sulfate. You'll notice that there's 1 copper, so we have 63.55. You have 1 sulfur, so 72.07. And then you have 4 oxygen, so 4 times 16, giving us 64. Add those all up, giving you a grand total molar mass of 159.62 grams per mole of CuSO4. Huge. Don't want anybody to miss any points or to get confused when completing their math assignments. And that is molar mass should never, ever, ever be written in scientific notation. So this is really what we came here for. Molar mass, molar conversions, or Avogadros number, they're important, but this is how we convert. This is our roadmap. This will be your lifeline when it comes to molar conversions. So there's really 4 factors that we're going to have. So if you're going from grams to moles, you're going to have mole up top because it's what you want, and you'll have grams on the bottom because that's what you have. If you go the opposite way, you're going to have grams up top and you'll have mole on the bottom. The same is true if you go from moles to particles, which is all of those atoms, molecules, and formula units and ions. So this one, if you're going from particles to moles, mole will be up top, and you'll have whatever particle you're dealing with on the bottom. The same is true going the other way. So you'll have particles over mole. Now that's all fine and dandy, seeing it that way and being able to write those general factors. However, we want to be able to actually do it on some math problems. So I'm going to go ahead and show you some sample problems, and I'm going to give you some hints as to how you know how many steps you need to have in your problem. So the first one, I know it says one stop on here, but how do I know that it's one stop? Because it's not going to always tell me that in my problems. Well, how do I know? It has the word mole in it. If mole shows up at any point inside of your the worded problem, it's only one stop. So you set it up. Mole's up top first, so then mole goes on the bottom, and then you need to go to grams because it asks you to find it in the mass. So you look at your periodic table. Mole always gets the 1. Copper is 63.55. And you take it, plug it into your calculator. You should multiply it, and you should get something in your calculator that looks like that. 3 sig figs right here in our givens. So our final answer is only 2.22. And then we moved it over 2 places, giving us 2.22 times 10 to the second grams of copper. Now I have the second one, the work shown for you. I'm going to give you a countdown from 3, and then I will show you the work. However, I would like it if you guys would give it a shot. And that's going to be 3, 2, and 1. So for question number 2, it says how many moles of NaCl is equivalent to 11.9 grams of NaCl? Well, right there's mole, so it's 1 step. Grams is at the bottom, so we're going to put that gram molar mass, and mole gets 1. Now the gram molar mass, I believe, is 58.44. Okay, it's 58.44. You divide by 58.44, giving you this final answer in your calculator. Since we can only have 3 sig figs due to 1.19, we're going to round that 3 up by the 6, giving us 2.04 times 10 to the negative first, because I moved it back 1, mole NaCl. That's half of the one-step problems that you might see. Let's go to the other half. This one's again says mole, so it's 1 step, but it gives you the atoms of silver. So we need to start out with that over 1. Now we're going to multiply it, and we need to get to mole. So we can go directly to mole. So mole's up top, and atoms down on the bottom. Now, when I see this, mole always gets the 1. Anytime you see particles, so atoms, ions, molecules, formula units, that gets Avogadros number, which is 6.022 times 10 to the 23rd. Now, you might notice that 3.01 and 6.022, this is about half of it. 23 and 23, when you divide, you're going to subtract. So my guess is that's 5.00 times 10 to the 0 mole Ag. Let's take a look. -1, because I forgot that you're going to get this in your calculator. Something about that, times 10 to the 0. And since we move it back, that gives us the -1. All right, I want you guys to try the full one on number 4, and then I'll show you the work. 3, 2, and 1. On number 4, again, we have mole in the problem, so we started out on mole this time. And we're asked to go to molecules. So that means molecules goes up top, and mole goes on the bottom. Mole will always get a 1 in our factors, and then molecules in a factor, not the given, will get 6.022 times 10 to the 23rd. So in this one, we're taking 1.5 and multiplying it by 6.022, and if we need to change the exponent, we will. However, when you multiply that, you get an extra half here. So my estimate would be that it's 9.033 times 10 to the 23rd. Let's see how close we are. 9.03. The reason that we only have 3 is 1.50 is only 3 sig figs, giving us 9.03. We're almost there. One more slide. And these are putting it all together. So how do I know that it's all together? Because nowhere there's no mole. So that means that my first step is going to go to the mole, and then from the mole, I can get to where they asked me to go. So for example, this one, it is 1.20 times 10 to the 8th atoms of copper over 1. Since I'm in atoms, atoms are going to go down to the bottom. Up top will be mole. Now that I'm in mole, mole will come down on the bottom. And grams will come up top. So we know that mole always gets the 1. If I see grams, I think periodic table. If I think periodic table, I think grams. So that's going to be 63.55 grams. And when I think atoms, I'm thinking Avogadro. Or if I think Avogadro, I'm thinking atoms, ions, molecules, or formula units. So that's going to be 6.022 times 10 to the 23rd. Now, on this one, what I would recommend is you take the 1.20 times 10 to the 8th, multiply it by the 63.55, get your top. And on your bottom, you'll have 6.022 times 10 to the 23rd. Okay, so if in my calculator, I'm going to go ahead and do this math for you guys. And you should get a number of 76.26. I'm going to move it over to 7.626 and make it times 10 to the 9th. Now, 9 minus 24 is negative 14, so we should be at negative 14. Let's check. And 1.27 times 10 to the negative 14th grams of copper. That's really not that much copper, and you can tell because there's not that many atoms. All right, I want you guys to try it. It's going to be the opposite. So we're going to go backwards this time. I'll count down from 3 so you can pause it. 3, 2, and 1. So in this question, we're starting off in grams. You can put it in scientific notation if you like, making it 1.224 times 10 to the first grams of copper to sulfate over 1 times. Now, since grams are up top, grams need to come on the bottom. Mole needs to go up top. And the next one should have mole on the bottom. And formula units. Now, I'm going to abbreviate this down to form 4 and then use. And that would be CuSO4. Moles get 1. If we go back, we have that molar mass in our notes. Right there, 159.62. And then this is Avogadros number. That's a 3. So you multiply them and divide. Again, I recommend you make that additional stop before going here. And your final answer, however, for sig figs here, final answer as 4 sig figs, giving you 4.618 times 10 to the 22nd form units, copper 2 sulfate. All right, class, look, I know that these can be a little bit difficult. We've seen this kind of conversion before in chapter 2. Just let me know if you have any questions, and we'll get you through it.